presentation. All right, so Tim's going to start off with some PowerPoint, and we'll go over the GIS and managing it in the cloud.
Good morning, or good afternoon, or good evening, depending on where you are. Thank you for joining. My name is Tim Kearns, and I'm on the Maritime team here with Esri in Redlands, California. Brinton is also on the Maritime team, and we're joined by a few others on our team. We'd like to share with you today some of the work that we've been doing with regards to managing and serving bathymetry data in the cloud. It's relatively new technology for Esri in relatively new directions. We've been calling this the Bathymetric Information System, obviously parallel with the Geographic Information System, and it's really GIS-based computing in an enterprise environment or in a desktop environment that you can manage and deploy your data quickly and easily. Some of the things that we're going to cover today, managing bathymetry data in a GIS and how we do that, how Fledermaus and Arcgis are working together. We recognize that many of you are likely Fledermaus users already, and you may be Arcgis users, or maybe vice versa. So we'd like to show you how some of the aspects of the applications are working together. We'd also like to show you how we update seamless seafloor surfaces in ArcGIS, how we share that bathymetry data with cloud-based computing, how we access it, and then we'll close off, and we should conclude with enough time for some questions. So to start, the first thing that we wanted to cover is, well, why are we doing this? Why is Esri doing this? And the main reason is because we really want to solve problems and make things easier for people who are using this type of data in a GIS-based environment. There's lots of applications out there we recognize that are specifically tailored for bathymetry, and they're very good, very powerful. Some of them have been around for a very long time, but they're also very focused, and they're not necessarily optimized for integrating with larger GIS platforms. And that's exactly what ArcGIS is. It's a GIS platform for managing spatial information, not just bathymetry, but a host of other applications and data that can link up within an enterprise or spatial data infrastructure. It can be part of coast and marine spatial planning. It can hook in with oil and gas. It can hook in with science. It can hook in with defense and ports. Right? There's lots of applications where bathymetry can hook into. And so it's not just for the hydrographic community anymore. It's really about spatial data and it's seafloor data, and we want to solve problems and make it easier for people to use. Some of the problems that we wanted to solve, some of the complex algorithms that are already out there, many of the data formats, there's reams of formats that are out there, some of the surface modeling problems, contouring, extracting soundings, and just generally making bathymetric data available in formats in a manner that's easy for people to consume. And that's what we're going to try and show you today. So when we are talking about bathymetric data in ArcGIS, what are the four main things we're talking about? Well, the four things are soundings and depths, and there's a subtle but important difference. Surveys and managing surveys, and that's everything from the actual survey report in PDF form to maybe the sound velocity casts that were associated with the individual survey lines, to the nav lines themselves and the survey planning. All of that information can be stored and captured in ArcGIS. Gridded data, many of you work with elevation surfaces of the seafloor, terrain models, bags, continuous surface models, virtual models, right? There's a variety of different names for them, but it's, at the end of the day, it's really gridded data, and we've really built a fairly robust solution that is specifically designed to handle that in a bathymetric context. And then metadata. This is the industry that we're in is, we can say, does not have a lot of standards for metadata as some other industries do, and I think that's just a natural evolution to our industry. But as a result of that, we are trying to build a metadata story and a metadata engine that will be shareable and not only ISO compliant, but I guess in a manner where other people can use and reuse and customize and share the metadata across data sets. All right, so all of this led to a bathymetric vision for Esri. And what does that really mean? Well, it's really enterprise-based deployment of GIS data and applications for bathymetric data, metadata, and products that it's a commercial product, and that's what we're really going for here. We call it COTS, which is commercial off the shelf. We know, and we get a lot of feedback that people really appreciate that ArcGIS is a very flexible platform that you can adapt it, and you can customize it, and that ranges from anything from making simple models in the geoprocessing framework that we can show you today, right up to coding C++ and in the .NET framework with Arcgis. So it's really a flexible platform. We didn't want to go out of the starting gate, so to speak, forcing people to configure and do a lot of extra customization on top of ArcGIS to make it work for them. So that's why we got led down this path and brought ourselves down this path of making a bathymetric product that is truly COTS. It should do almost everything that you need it to do for bathymetry. And if it doesn't in the first release, then we'll add it in over time. So what are the technologies that it includes? Well, it includes the Nautical Solution, which is a product from Esri, and that includes ArcGIS Desktop, ArcGIS Server, many of the extensions, 3D Analyst, data interoperability, but it also includes Fledermaus, and this is where many of you are already familiar with this product, but we recognized early on that there was a natural harmony between Fledermaus and ArcGIS. Fledermaus is an extremely robust desktop-based application that does visualization, analysis, modeling, and ingest and QC of bathymetric data. ArcGIS was weak on that front, but ArcGIS had a very strong database-driven, centralized enterprise management system, and that was one of the areas that Fledermaus hadn't focused on. So by marrying the two products together for an end-to-end bathymetric solution, we feel we have a really good offering here, and we're really excited about this relationship. Now we've got limited integration between the two products now. We're going to show you some of that today, but we're going to continue to integrate the two products over the coming months. We also add in QPS. Fledermaus is now by IBS 3D, which is also QPS. QPS also has technology that we're looking at including, and we're just entering those discussions with QPS in Portsmouth and the Netherlands now. All right, so when we look at who benefits from bathymetry in ArcGIS, we're really looking at a pretty wide array of customers. We've got people who are in the oil and gas sector. Clearly, the hydrographic offices are long-standing customers, the defense community, coast and marine spatial planning, habitat mapping in the science community, engineering, ports, and then, of course, this new emerging market, which is base map and online content. These are people who are, these are my dad and your dad who want to do stuff with GIS but aren't GIS users, but they have access to it through web-based computing, whether it's Google Earth or ArcGIS Online or ArcGIS Explorer. There's a variety of different online applications now that have data, that have tools and analysis and services that people can do things with. And we want to make it easy for people to have that access to that data without having to be a specialist in hydrography. There's one common thing, though. When we bring all of this together, all of these people have a shared goal, which is really to work with bathymetric data that is easy. It saves them money if they're in a profit-driven organization or they're budget conscious, which most of us are. And they want to not only do something with the data, but they have an output at the other end. That output could be a hydrographic nautical chart. It could be a seafloor model for rig planning in the Gulf of Mexico. It could be for planning routes across the Atlantic Ocean, or it could be in the science community for modeling in the benthic habitat for high-resolution models of coral reefs off the coast of Florida. There's a variety of things, but it's all the same common goals and objectives, to work with bathymetry data in an easy-to-use manner that others can benefit from. All right, so when we look at what the BIS is, or the Bathymetric Information System Overview is, it's really four main components, and you'll see some of that today, and you'll see more in the coming months. So we've got the first one, which is getting data into the system. So this is validated data. We're not having any illusions about reinventing applications that process data on the ship and clean it and then modeling that in ArcGIS. ArcGIS strength is really about modeling and managing data, and we don't have a history of doing the data cleaning. And there's other applications that are out there that do. Fledermaus is one of them, and we're looking at those as inputs to the BIS system. So that blue can in the lower left, that's really the central database where bathymetry data is stored and managed. But it's not just a database, it's a geodatabase, which means it's geospatially enabled in an ArcGIS context. It doesn't matter to us whether it's SQL Enterprise, SQL Express, Oracle, DB2, Informix, or Postgres. We support a wide variety of databases, and it's really that application layer on top of the database that makes it spatially enabled. The next main part is management. And so management for us is 4 components. It's gridded data, which you'll see clearly today. It's point data. It's survey bundles or survey packages of information about the survey, and then it's the metadata itself. Managing and serving this stuff is what is one of our strongest strengths, and it's something that we're going to show you how we do today. That quickly plugs into the next part, which is the access. So you notice lots of little clouds there, and that's because most of the access we're talking about is cloud-based computing. Lee's going to show you how we do that. It's very simple, very easy, and we're hopeful that you'll like it. And the last part is consumption, and consumption really varies. This is more workstation-level applications of working with bathymetry data. It ranges from creating seamless surfaces at the workstation to outputting products, whether they're contours, selected soundings, high-resolution models of a selected area, maybe TPU surfaces as well. It also includes tools and services, and it also includes the integration with Fledermaus. And Lee's going to show you some of that today, how we've integrated in a seamless manner, actually, inside ArcGIS, but behind the scenes, it's actually Fledermaus that's working. All right. Now, we do have much capability available to us at 10.0, which is the release that we're on right now. We're going to formalize that, and so we're going to formalize that at 10.1. If you were to go to the ArcGIS website today and look for bathymetry products, you won't find one. We've only got what we've tailored the COTS software to do already. At 10.1, which we're releasing early in the new year, we'll have a suite of tools which will be included with the nautical solution, and it's going to include these applications in the big blue bubble. Server, desktop, Fledermaus Pro, and whatever, I believe it'll be 7.3 will be the version at the time. It'll be bundled with nautical solution, and it's going to come with a variety of tools, services, metadata, configuration parameters, and a certain amount of flexibility built in, but certainly capabilities to help you manage and work with bathymetry data in ArcGIS. Some of the things that will include workflows, a data model, tools, models to do analysis, of course documentation, plus some pieces that we're working on right now which we can't show you today. A metadata engine, something called the BIS Explorer, building surfaces dynamically, managing those surfaces, which we'll show you a piece of today, and then even more on the Fledermaus integration. It doesn't prevent users, however, from continuing to adapt and configure the software. We want COTS-based software, but we also want it to be in the spirit of ArcGIS technology, which is adaptable and configurable, which means that if it doesn't do quite what you want it to do, or you're looking for a different look and feel, then that option is available. And like I mentioned earlier, that ranges from anything from building simple models in the geoprocessing framework, which you almost don't need any GIS knowledge for, to some custom development using Python and building workbenches with data interoperability, to advanced programming with ArcObjects, and ultimately even building your own applications through ArcEngine. And this is mostly at the desktop level, but this also extends to the web as well. And we're architecting the BIS to be able to plug easily into the web so people can build custom web applications and interfaces to work with bathymetric data. I'm going to turn it over now to Lee, who's going to show you a little bit of an overview of ArcGIS. We recognize that many of you may not have seen ArcGIS before, or maybe you're experienced users, and if so, then just sit back, relax, and enjoy the ride. But if you're new to it, Lee's going to show you a little bit of ArcMap, a little bit of how data is organized in ArcGIS, the Task Assistant Manager, managing data in ArcMap through our catalog, and then the geoprocessing toolbox. They'll round it out by doing a sounding extraction. This is one of the capabilities where we've already integrated with Fledermaus behind the scenes, although you won't see Fledermaus pop up. It's actually running behind the scenes, and it's working directly on the geodatabase. And then he'll also show you how we would go through the workflow of updating the nautical production system.
Thanks, Tim. All right, good morning, everyone. So hopefully you can all see we're looking at ArcMap right now, and ArcMap's a one-stop shop where you can edit, manage, and share your data however you would like. I'm going to give you a quick tour. Right now we're in Massachusetts Bay. I'm looking at a continuous surface. You might be able to see some green lines. I'll turn those to a different color so we can see them a little bit better. They'll be red. Those are the footprints of every data set, but this is actually behaving as one single surface. Other things that you'll see here is on the right, I have an ArcCatalog window. ArcCatalog is, you could think of it as Windows Explorer for your GIS data. It's a little easier to manage your data, to manage the supporting files, maybe projection files, or maybe files that store statistics about a data set. ArcGIS or ArcCatalog will actually manage that for you, so you don't need to worry about it like you would in Windows Explorer. So below here we have ArcToolbox. ArcToolbox is the window to our geoprocessing framework. Really, it's just a list of tools that allow you to do anything from buffering points. So if you want to put a 20-meter buffer around a set of points, you can do that. If you want to calculate the slope of a surface, you can do that in our toolbox. You can also create models, so you can link together multiple tools and get a custom output, and it really streamlines your workflow. Beyond that, you can create scripts, and this is really where we tie in with Fledermaus. Fledermaus has a series of tools that we really like and we really want to use within ArcGIS. So we've created a simple script that calls the functionality from Fledermaus behind the scenes, and will actually do the processing right within ArcMap. And I'll show you that in a little bit. On the left-hand side, you have what's called the table of contents. Table of contents is just a window that manages all of the layers that you are viewing in your ArcMap session. So here I have my surface, my M cover, and a few other things. You can turn those on and off. You can change the priority in the order list so that one's drawing on top of the other. Just simple little things. Okay, so we're going to get right into it. What we're looking at is a chart cell that's overlaid on top of the surface. You can tell that I have a bit of a hole in my surface, and we're going to fill that in with a Timbit later. That's a little joke I've got on my surface that's going to fill that hole. And what I would like to do is do my sounding selection first. So let's zoom into a selection. I'm going to turn this on, and you can see here I have a surface. What you're looking at are the soundings you see are actually stored within the nautical information system, and that's our sister team, and they manage all of the products that you can create, like SUT7 cells, charts, anything, AML layers, yeah, and it just goes on, the list goes on. So that's in black. If you want to do a sounding selection, we want to do that based on a certain chart scale. So the chart scale of the chart that we were looking at is about 100,000. I'm going to go into my Arc toolbox. That is under extraction. So I have a series of bathymetry tools here. I should probably point out the bathymetry tools, you can do compilation, extraction, and loading. Right now we're just going to focus on the extraction of soundings. So I'm going to expand the from raster sounding selection. So I'm going to open this up. I'm going to specify my surface. So what we're actually doing is this is a tool that looks like an ArcGIS tool. Really, it's not. It's just a window into the Fledermaus functionality. The GUI that you're looking at, I just made quickly with a few parameters. I just right-clicked on a script and said, okay, I have a parameter that's input raster. I named that raster. It knows what to do based on the script. So I'm going to give a name, sounding 100. Should be 100. I'm calling it chest, but I'm going to give it a scale, 100,000, and then I'm going to give it a spacing. And I'm going to let that run. This will take maybe 48 seconds. What it's doing is actually analyzing the surface that we're looking at, looking for the shallowest values, and it's going to output a point feature class. This point feature class is actually being written directly into the geodatabase, the Esri geodatabase. So Fledermaus has the capability of creating soundings, creating features in our geodatabase. It doesn't actually need to create anything on their side, like a PMF or create their scene document. It just writes it directly into our geodatabase. Once that's done, I'm going to turn this. I'm going to turn that layer on. We'll be able to see it symbolized with the sounding values. Let's take a couple more seconds. Might be a little bit slower today because we're using the GoToMeeting. There we go. It's just completing, and it's going to wrap up. One thing I should mention, I've taken a look at the results before this. Hit close. It's complete. I'm going to turn this on, and here we go. One thing I should mention, the placement of the sounding labels are actually they're just to the northeast, and you can adjust those accordingly to be more cartographically appealing for the nautical product with the nautical solution. So you can see those in red. I can now do a replace. I can copy that layer and paste that directly into the NIS, which is down here. And since they're both databases and they have common attributes, it's as easy as just a copy and paste directly in from one database into another database. You're doing this all within one application. I don't need to open up multiple software packages, export anything. I don't need to write my data into another system.
Something we should also mention, when you do the copy and paste and you're doing a replacement of those soundings or a batch update on the NIS database, those soundings aren't deleted. They're removed from the active layer. We manage that through version management on the geodatabase side, so they're actually archived. They're flagged with the reason as to why they were deleted or put into the archive, and usually that's a new survey has come in, or perhaps a new dredge survey has happened, and the waters are a little deeper, and those data points need to be replaced. But it is important to note that nothing gets deleted off the production side. It's just archived into version control on the geodatabase.
Okay. So I'm going to zoom back out, so we'll get ready for the next demo, and we're going back to the PowerPoints.
Okay, thanks, Lindsay. Well, we wanted to slide in now to how we're managing gridded data, and that's the focus of what we've been spending our time on, and it's one of our real strengths. And the other reason why we're doing this is because many organizations around the world have got potentially terabytes, but certainly gigabytes of gridded data that is not necessarily intuitive or easy to work with, especially in a seamless surface manner. And so we wanted to show you some of that today. Lee's already demonstrated how we're visualizing seamless surfaces in ArcGIS, and he's going to get into some more details in just a few minutes. So when we look at two fundamental approaches for managing gridded data, we really have the enterprise system on the left and then file-based system. So I'm sure that all of you watching are familiar with either one or the other of these. On the enterprise system, they're usually relational databases. Getting data in or getting data out usually requires an import and an export, which usually is a copy of the data because you've got to put it into the proprietary format of the database. Even if it's just an extra row in the table or as an extra blob in a field, it still takes up additional space. We just had a question a few weeks ago about, well, if I've got a terabyte of data, how much space do I need on my relational database so I can manage it all? Typically, when it does move into a relational database, it gets severed with the source data. That link, gets severed. And in often cases, the metadata is not maintained. It may import, it may not import. It's a bit of a fingers crossed, wait and see type of activity when you do that. Now, going to the other extreme, we have file-based systems. The source data typically works directly with the application. One of the downsides, it's difficult to scale because it's either RAM-based computing or it's limited to a workstation-based environment. Generally low interoperability, and that's because, as I mentioned at the beginning, these are very tailored, very specific applications. And as far as deploying the data products that come out of these systems, also somewhat limited capability. And so we looked at both the pros and the cons of both of these, right? And there are definitely pros and cons. And so when we came up with our solution, we actually came up with a hybrid approach. It's a relational database system plus a file system. It eliminates data duplication, and all of the original data is preserved. And we'll show you how we're going to do that. The advantages of this is that we've got the integrity of all of the files themselves managed through a bathymetric database, but it gives us the flexibility to work with them through a variety of interactive technologies, whether they be desktop, mobile, web-based computing, or server-based computing. So how are we doing this? Well, behind the scenes, it's Mosaic dataset technology. There's lots of documentation on this out there. This is very powerful technology. It's been developed over the last few years at Esri. It's not just for bathymetry. This is technology that's being deployed for high-resolution aerial photography, satellite imagery, LiDAR-based imagery as well, and we are now adapting it and making it available for the bathymetric community as well. So Mosaic dataset works directly with gridded data. Now the examples we're going to show you today are with bag data, the most common and the sort of de facto standard, I guess you could say, for gridded surfaces that are specifically tailored for hydrographic needs. It generates on-the-fly surfaces. Now Lee already showed you this, and he'll show you some more details in a few minutes, where what you're looking at is, yes, it's a seamless surface, but in the background it's actually pulling from the original source data. It's not storing it on the geodatabase, it's just managing it through the geodatabase. Once it's a seamless surface, then there's a variety of things you can do with it. We can do that through things called functions, and if we have time, then we will show you how we do that. As you can see in this slide, we've got a few characteristics about the Mosaic data set. We have a bounding footprint for each of the data sets, and we briefly showed you that. On this image, you can see we've got 4 red boxes surrounding a representation of some input data. We also have a total bounding footprint, and this can include no data areas as well. And then we've got the image content itself, and the image is being displayed as an actual seamless mosaic. And there's a variety of different ways that mosaic can be constructed. It can have different priority settings. It can have different draw orders. It can have different attributes associated with it that allow people to do queries and make selections based on that. So there's a variety of different things that we can do with the seamless surface. Okay, here's the functions that we're just discussing. Now, a function allows you to generate new content from the original source data. All right, so as you can see in the upper left, we've got the elevation content. This is just obviously a land-based example. We've got elevation content, and then from that, we've got a series of derived models that come from that. These models are derived on the fly, so it doesn't matter whether it's a hillshade, shaded relief, TPU model, slope, or aspect. It could be a variety of things. The important thing to note is that we're not copying or duplicating any data that already exists. We've already got the data, and it's not copying it again. It's just generating on the fly. Conversely, when you update the original source data or replace it or add to it, then you're also going to update those models or those downstream effects applied through functions. So they're pretty simple. We've just got a couple of screenshots, and Lee may be able to show you that. There's a whole host of them. The other advantage of this is that you can create your own custom function. So if you've got specific scientific applications of the data that you want to do, you can write your own function, add it into ArcGIS, and then apply that to your source data. The functions can be applied to either the original input data, or they can be applied to the Mosaic data set as a whole. All right, so Lee's going to show you how we do some work with managing file-based data inside a relational enterprise geodatabase system.
Thanks, Tim. Okay, so we're going to talk a little bit about the Mosaic data set and that continuous surface, like Tim was saying. So if you look here on the right-hand side of my Arc catalog, I have my Bathymetric Information System database. I'm going to expand this, and you'll see several Mosaic data sets. These icons that you see in blue with the three little rasters overlapping, that's the symbol for a Mosaic data set. The three Mosaic data sets you see here, gridded surface TPU, gridded surface mass, are all sourcing the same raster data on disk. I can have a server that holds a terabyte of data. As long as my database can point back to that server that's holding that data, I can create however many Mosaic data sets I would like from that set of data, that set of rasters, without duplicating that data as well. So the functions, where that comes in handy are those functions. Typically, if you want to represent your elevation data or your depth data as a hill shade or a shear relief or compute a slope on it, you would need to use a geoprocessing tool and then let it run. It would output a new data set, and that really duplicates your data. Instead, we would create a Mosaic data set, and that's just a record in the database. It's just pointing back to the original source data. Then I would apply a function. That function, say slope, will just on the fly compute the slope surface. Since it's just a representation and displaying it to you on the fly on the screen, there's no duplication of data. If you have a terabyte of data, you still only have that terabyte of data. So we're going to look just at, I can show you quickly where that actually is stored. So what you see here, the bathymetric data, that's the gridded surface mass. I'm going to go into the properties of that, and there's a tab for functions. I can right-click on the Mosaic function and insert. Here's a list of all the functions I have. I can apply and extract bands. So this Mosaic data set is really built of bags. Bags are two-band raster surfaces. It's automatically picking that up and saying you have band 1 and 2. What would you like to extract? I can say I want to extract band 1 or I just want to extract band 2. If I do 2, it's going to show me a representation of just the uncertainty band in that data set. I don't want to do that right now because I want to do some more computing. Well, as I said earlier, my surface looks like I have a hole in it. It looks like a donut. I have a raster data set that will fit in there, but that's on my external hard drive. I don't want to keep my external hard drive plugged into the server forever, so what I would like to do is copy that over to the main server. So here you can see my F drive. I'm going to expand that. It's taking a second.
So Lee, so a real-world scenario of this would be if I'm in the field and I've just completed a hydrographic survey, maybe a small one in this case, and I've come back and I've got my external hard drive that I've taken off the lab on the ship, and I'm handing it to you, the production manager, in the back in the office.
Sure.
And that's what's happening here?
Yeah, I would take your hard drive or your CD. I would plug it into my computer, copy it, like I'm going to do here. I'm going to copy, and I'm going to point to my data store where I keep all of my other rasters, and I'm just going to paste that in. It's just going to copy over. It's taking the actual raster data set. It's taking any associated files like metadata, and it's bringing that over as well. So here you can see it's brought over, and now I want to update that. So since Tim just got off the ship and he gave me all of his data, I want to update that. I want to update the surface so my customers can see the changes. So in the Bathymetry toolbox, we have a loading toolbox. Inside the loading toolbox, we have an add bag to BIS. So I'm going to double click on that. And this is a quick script that I've created. It's focused on just looking for bag data sets. You can have this designed to look for TIFFs or anything you want, but since this is the BIS, bags are really almost the standard for bathymetry data, so we've written it for that.
So we've got a question here, Lee, that we should take a moment to answer.
Mm-hmm.
So the question is, are all the soundings in the BIS a common vertical datum? And so there's two parts to this answer. And for what we're planning on doing right now and what you're looking at today is all of the input data sets can be in their own vertical reference system, and that's okay. We're not transforming everything into a common vertical datum at this time. We are looking at adding vertical datum transformations on the product generation output side of the story, if you will. So you're looking at seamless surface mosaics in ArcMap, and they could be derived from either points or gridded data. But when you output that to essentially a seamless surface, whether that surface is made up of points or gridded data, then yes, we will have to do a transformation at that time. We're still building in the models at that part of the system, and we hope to have something at 10.1.
Yeah. That's a great point, Tim. One thing that I should probably point out is this surface is multi-resolution. Since it's about 30 raster data sets, each one has a different resolution. Some are 5 meters, some are 10 meters, some are 1 meter. Beyond that, these data sets have different coordinate systems. One could be state plane south, the other one could be WJS 84. Whatever it is, ArcGIS is smart enough to reproject on the fly to a common coordinate system. Right now, the Mosaic data set is WJS 84. So it is aware of what the input data sets are in, whether or not it's state plane or Mercator. It will reproject them and display them as a common coordinate system. So you don't have to worry about reprojecting your original data and then pre-processing it, getting it ready to be all in the same coordinate system. So I'm going to input, I'm going to go back to the workflow. I want to update my surface. I'm going to navigate to my gridded survey data. I'm just adding the workspace. I'm going to specify the Mosaic data set that I want to update, and that's gridded surface mass. Add. I'm going to hit OK. So what's happening here? I specified a workspace. So the tool is going to work. It's going to search through the workspace. It's going to look for any data set that is new. It's aware of what rasters are inside that surface, and it's going through and checking off like, okay, you are in there, so we don't need to add you again. It finds a new data set and will add that into the surface. It applies a pyramid so we can see it faster and at larger and or actually at smaller scales. And then it's also going to calculate the statistics. So in case there's a deeper value, it'll look smooth. So it's completed. I'm going to refresh that surface. And there it is. Now I've filled in my surface.
With your 10-bit.
With my 10-bit, yeah.
So we've got another question here, and the question is, when we're working with disparate survey data over time, how do we handle spatial temporal data inconsistencies? So what's important to point out here, and if I understand the question correctly, we're just continually adding data into the system. We can filter and do queries based on metadata and based on the attributes of the input data sets. And so what Lee's showing you is just one seamless Mosaic data set. This is not the Mosaic data set that you would necessarily work with on a day-to-day basis, because this is going to grow over time and will eventually include all of your data holdings. Now, as you can see in our example, we're just showing you a small subset of what could potentially be hundreds or thousands of input surfaces. In the BIS at 10.1, and probably in a few months here, we'll have a sort of what's coming with ArcGIS Bathymetry at 10.1. What we're going to do is have the ability to extract surfaces, seamless surfaces, based on a variety of input parameters. So if we do have overlapping data that has been captured over the same geography over time, then the user will have the ability to make queries and discoveries of that data to make a selection or a decision based on what their output needs are. If it's the same data, if it's the same values, then it won't really matter. But if it's shoaler, perhaps, and it was shoaler collected in the earlier survey, and the output is going to be a navigational surface, then it'll be important to have that take priority over the newer content. If it's higher resolution and the desire is a high resolution model, then the higher resolution model will take priority over the coarser resolution, even if it's perhaps newer data. We'll have other abilities like extracting based on TPU. So a higher quality of survey could be extracted over a spatial area. So I hope that answers the question, and certainly send us, we can communicate after the webinar if you've got more questions on that.
Thank you. Okay, now we're going to switch over to back to the PowerPoint, and Tim's going to carry on.
Okay, well, we've done a lot of talking about working in a workstation environment, managing bathymetric data. We're gonna wrap up and shift focus now to working with the bathymetric data in the cloud. And this is pretty exciting for us. This is relatively new. Esri has gotten on board early on working in a cloud-based environment. But what's not new to Esri is working with a server-based environment. We've been doing web mapping for 15 years now, and we've really taken that to new heights with the release of ArcGIS 10. So we've got a new generation of ArcGIS Server. And ArcGIS Server is the product line that's specifically geared for publishing content to others through a variety of means. And those means could be through web, mobile, workstation-based technologies. And it's not just bathymetric surfaces. This is really, we can publish tools, you can publish the survey data, services, metadata, points, vector, products. There's a variety of different services that can be published onto the web. There's also a number of standards, obviously, that Esri supports and has been a long member of the OGC community. WFS, WCS, a host of other services, KMZ, you name it, we pretty much support it or we're part of development. One of the advantages of ArcGIS Server at 10 and even more with 10.1 is that it's very simple to use. Lee is going to give you an example of just how simple it is, and we hope that you'll be satisfied with it. When we talk about real cloud-based computing, what that really means is it's a cloud-based environment to do geospatial management, analysis, visualization, and mapping. You do not need to be a GIS expert. You don't even need to have GIS software in order to do it. It's really about just accessing content that others have made available to you through the cloud. Esri has their own cloud that we host and maintain through one of our other facilities. We also work closely with Amazon as part of the Amazon cloud, and then we have a very close relationship with Microsoft as well. The content that's on the cloud could be hosted and authored by Esri, which we do for much of our content, but we also have a whole community of GIS users, and they could be authoritative users as national governments, for instance, or local and state and regional governments, but it could also be just regular GIS professionals who have content that they want to share with others. Lee's going to show you an example of how we do that and how others can access it. So when we look at ArcGIS Online is part of a whole system. Arcgis.com, which is the area that Lee's going to show you, is really just the portal into ArcGIS Online. Arcgis.com allows you to create and share maps and data. It allows you to access and discover through very simply used search tools, and it's not just maps, it's mashups, it's services, tools, and data that other people have shared, and then it allows you as a user to share your own content. And this is where the real power of ArcGIS in the cloud comes from, is because then you're sharing content that's in a really easy-to-use manner. It's a simple, easy-to-use interface that presents to you complex data and complex geospatial information. Okay, so I think we'll turn it back over to Lee, who's going to show you publishing bathymetric surfaces through ArcGIS Server, and then also consuming that in a cloud-based environment.
Thanks, Tim. So you're exactly right. You don't necessarily need a GIS software to use GIS data. But first, before we do that, I want to make data available to my friends or my colleagues, whoever it may be. So I just switched over to my server machine. This is my desktop machine that we're looking at here, and I've done some editing. I'm going to switch over to my server machine, and this is where I have ArcGIS Server. Now we're looking at the same surface. I've got it with a different color ramp, just grayscale. But what I really want to show you is how to share this. In the Arc Catalog window on the right, I can right-click on this and I have an option to share as image service. So I want to do that. I'm going to go through the wizard and say I want to publish it onto my server. I give it a name, demo. Hit next. And it's going to bring up a window. This window is going to give me the option to apply certain capabilities so that my users can, or my friends can even can download it. They can add data, or they can add content to that service. They can query the pixels, and they can do measuring. They can measure maybe a profile across the surface. So right now we're just getting some basic parameters. You can modify any of these, but really I want to show you are the capabilities. Right now it's imaging. If I check on WCS, which is the web coverage service, it's dynamic. This window is dynamic, so same as web mapping service, it's dynamic. If I check that on, I can go into the web mapping service and review the capabilities. I don't want to set those, so I just want imaging.
And the advantage of imaging here, correct me if I'm wrong, is that it's the actual data content that's being published out. This is not just a JPEG or a representation of the data, that's the actual content, right, Lee?
Yes, it is, more or less. What it's doing is giving you the ability to use this data as a true data set, as if I were to send you the DEM or the bathymetric surface on a CD, but instead you're connected to it over the internet. So some of the capabilities that imaging provides you is edit, mensuration, which is the measuring of pixels, and download. Download would allow your users to make selections and download the actual data, the actual bag data onto their own system. You can lock that down through a series of security profiles, so it's not just open for the world. Editing would be the ability to add additional bags or add additional rasters to that surface. And pixels, it's not just a picture that we're sending you. It's the actual floating point, decimal point value. So when you identify, you can check that all out. And it's just a matter of checking those on. The last thing is the summary. You can give a summary. You can give specific tags. It's asking me to log on. This is how we publish this out to Arcgis Online. So I'm just going to log in here. This takes a second. It automatically detects the tags. So bag, bathymetry. Those are search keywords that will allow people to find your data. I don't want to publish this out right now because I've already got one out for you. So let's switch back over to the internet. So Arcgis.com. I'm going to sign in. Arcgis.com, it's like a social website for you to share your content or for you to access content. You can see here, since I published out that surface earlier, I have a gridded surface mass dataset in here. I can click on that, take a look. It gives me a thumbnail. I can share this either through Facebook, Twitter. I can share it to other groups, which I have. There's a group here called the Bathymetry for ArcGIS group. I've already shared it to them. So I'm going to go into this group. I happen to be the manager of this group, so I'll have a little bit more access than the typical user. But what I would like to do is make a map. If I click on my map here, I've already created a Mass Bay Nav and Marine Infrastructure map, and I can open this up in Arcgis.com. This is a free viewer that's a web viewer and allows you to add content to. You can save this and share it among whoever you need to. So I'm going to go add content. I'm going to search for layers. From my content, I know I only have that one surface, so I'm going to just search and hit add. What it's going to do is add this to the display. It takes a second. Should be, there we go. Sorry with the delay. So I've added that surface directly to this map. From here, I can share it. I can provide this to people, and they can access it either on a desktop application like ArcMap. They can access it on their own web application. They could do anything with it. Okay.
Okay, we've got a few questions that we should probably answer before we wrap up, and we're getting close to the hour. So one of the questions is, well, how are we managing points? So there's a variety of ways that points can be brought into ArcGIS. They can be managed through point feature classes, multi-point feature classes, terrain data sets, or LAS data sets. For 10.1, we're probably focusing on terrain data sets, which is the management of behind-the-scenes multi-point feature classes where point clouds can be managed through ArcGIS. This will allow us to query back to the original source measurements off of the derived surfaces that are generated. For Mosaic data sets, we're also looking at including points as part of the Mosaic data sets. That's not something that we have today, but we're looking at doing that for 10.1 or shortly thereafter. We recognize that when people want to query their surfaces, they want to have that traceability back to the original point, and that's why we're spending so much time on metadata. As the input surfaces, whether they be points or gridded data, with the surfaces that are created, we will maintain at the pixel level or the cell level the original source data where that came from. It may be through an ID, but if it's a derived data set, like gridded data, then it'll be through the input data set where it comes from. Let's see. There's another question as far as what type of algorithms are we using. The algorithms that we were using this morning for the gridded surface, they were actually the bag data set, so they were probably queued because I believe it was NOAA data and they were processed before we got them. However, if it is point data that's come into the system, either through Fledermaus or through other means, then there's a variety of different ways. Creating is one way, natural neighbors, other interpolation methods. There's almost a dozen of them, I think, supported by Archiescom. Or you can create custom algorithms, one of the strengths of ArcGIS. And so creating is just one such way that we can manage point data coming in. If it's single beam data, or in the case of Army Corps data office, it's transects across rivers, then it's probably best to triangulate that data before putting it into a gridded surface. So that's certainly an option, and terrain data sets make that very simple to do. I'm going to wrap up with a couple slides here, and then we can get into the rest of the questions. Some of the directions that we're looking at a full product release at 10.1, and that will include some additional Fledermaus integration with the inclusion of a toolbox and some more behind-the-scenes tools. The product release will be at 10.1, which we're looking at early in the new year, probably realistically the April timeframe. More updates on Esri.com as we get them, but that's the plan right now. We will be doing a series of webinars and training and workshops around the world to make this available for people. And we hope that you are able to participate in that. We're going to be generating a lot of awareness through our blogs and setting up a Bathymetry user community. And then we'll also be using this through cloud-based content. We gave you a brief introduction to that today, but you're going to be seeing a lot more of that if you just log on to archies.com and search for Bathymetry. We can't do any of this without building a community and having partnerships with people like you. If you've got ideas and feedback, we're very receptive and very happy to work with you. We've got a few customers out there that are interested already in doing prototypes or beta evaluations with us, and we're looking forward to working with you if that's something that you're interested in as well. So in summary, before we get to a few more of the questions, we're really looking at a hybrid approach to managing this gridded data. It has resulted in high efficiency, but preservation of the original source data. There's no duplication. If you've got 500 gigs going in, you've got 500 gigs in your system. There's really very little overhead to using a geospatial database to manage this type of information. The integration with Fledermaus is key for this system. We've got not only the experience of the company and the people that go with it, but also the support and the capabilities of the software, which are really key as the inputs and the interaction with the bathymetric data once it's in the system. Publishing to the cloud is easy. It's getting easier at 10.1, and we're really looking forward to interacting in a cloud-based environment. We put our contact information there. That will get broadcast to a few of us in the company, and we'll be happy to entertain any questions that we have at this time.
Hi, Tim. Thanks, and Lee. That was great. You answered a good portion of the questions. There were one or two that came in. So way back when you were looking at that image data set, I think you've created an image. Robbie Wilson asks, if you click on the image surface, do you get a Z value?
Yes, you do. In fact, I can show you that quickly. I'm going to switch over to my identify, specify that I want to identify on my image. And let's zoom in a little ways. So this isn't just a pretty picture, actually, and I didn't really zoom in a lot. As you zoom in, it's going to refresh and show you the source source pixel. What we're actually seeing here is the depth, which is 79 meters. It also doesn't just give you the depth, but it also gives you the data set that came from, and then it gives you the actual name of the data set that came from, and it should give you the TPU. Some of these data sets have questionable TPUs, so they're returning strange values, but data in, data out.
So all of the metadata that Lee was showing under the field there, that's configurable, and that some of that will come from the actual bag data, and then a lot of that will actually be extendable through the system, the BIS system. But then we're making it flexible enough that if people want to add or customize metadata, then it's very easy to do. It'll be ISO-based XML metadata.
That's a great question.
Okay, just as an aside before I say the next question, some of you guys asked what BAG stands for, and you probably don't know what TPU stands for either. A BAG is a bathymetric attributed grid. It is a grid data set with X, Y, and Z information, but it also has the uncertainty for the Z depth. So that's a BAG. TPU stands for total propagated uncertainty, and that's that uncertainty information that's associated with the depth value for the gridded data set. Okay, does ArcGIS.com allow you to display z-values for the DEM?
Yes, it actually does. That's all based on the capabilities that you provide when publishing out that service. So like I said, when we can check on that pixels capability, that gives you the ability to query on a pixel level.
So as Lee said, that could be locked down. If you've got elevation or if you've got data content that you want to restrict from people, then you could also set that up. So you could publish the full data set, but set it up with different user roles and permissions. So if you've got maybe, let's say, people within inside your organization or an internet domain that you may want to give access to the full data set, but perhaps the general public, you just want them to see a surface representation through even like an image, like a JPEG or something, then that's very simple to do. Set that up through our ArcGIS server and cloud.
Okay. Is the bathymetric tool, or the tools that you're showing, are they only part of ArcGIS 10 or also available in lower versions?
Everything that we've shown you today has been released software. The tools that Lee was showing specifically in the Arc toolbox that we've got on screen right now, the bathymetry tools in the geoprocessing framework, those were tools that we put together ourselves here on the Maritime team. It didn't require any actual professional software development. It was through modeling, Python scripting, and we're happy to make these freely available to anyone that's interested.
Great.
We can actually post these.
Go ahead.
Go ahead.
No, I just have lots of questions coming in, but finish your statement.
I was going to say, and one way that we can get this out actually is through Arcgis.com. We mentioned that Lee demonstrated sharing surface through Arcgis.com, but we can also share tools. And so this is something that we can publish out on the Resource Center, so we plan to do that.
Absolutely.
Great. Okay. With sounding data, within the sounding data is sediment information. Can that also be queried or retrieved? And I think that's a yes, right?
Yes, it is. It's just metadata attached to the individual sounding. We can pass that through to the surface if the metadata exists on the surface, but it shouldn't be a problem.
Okay. Oh, here's a big one. Any hint on how you're going to handle the intertidal zone? Did you hear me?
Well, I suppose it's a good question. I suppose what does that mean, the intertidal zone? Because that means different things to different people. If the question is how are we handling just I guess like where the coastline is, then really we're just using it based on the vertical datum of the input data set. And so if that is I guess if it's in line or adjacent to other data that has the same vertical datum that's land-based, then it should be fine. But all of our data will be managed through negative down for positive down, I should say. Sorry, negative down in the seafloor and then positive up in the land, and that's in line with Fledermaus. So I may have missed the intention of the question. If I have, then just please rephrase it.
Okay, I haven't heard anything back, but if we do, we'll ask again. Does the algorithm used for gridding meet the requirement of the nautical requirement? And I think if it's, you were mostly using bag data sets, correct?
Yes.
So yeah, that's a, I don't know whose nautical requirement exactly. I'm not sure where the question's coming from, but they want to know if the algorithm used for gridding meets the requirement of nautical organizations, I believe is the question.
Yes.
Right. So there's a variety of different ways that we can create the surfaces. And so this is what I was trying to communicate earlier. When you have overlapping data sets, or if there are data sets of differing quality, perhaps an IHO survey order, for instance, you can make a metadata query based on that and only use that as inputs into the output surface. Now the output surface, if it's going to be points, then you can also specify whether it should be shoal bias, deep bias, or I guess it really depends on what the output is for. But if it's for navigational products, then yes, you can tailor that.
Okay. A question is, can you combine non-bag data? So you have those bags in there. Can you bring in other random grids and combine those in your Mosaic data sets?
Great question. Absolutely, yes. If you have TIFFs that just represent depths, you can do that. I've actually got a tool here that's add DEM to BIS. That's actually just searching for any data set that is floating point, has decimal places. It could be a USGS.DEM, or it could be a .TIFF, and it'll add it in. So it doesn't need to be, a Mosaic data set does not need to have one format. You can put multiple types of data sets in that one container.
Okay, Lee, good answer. This question actually came up a lot in a lot of different ways from a lot of different people, and I did answer a few people using the text, but you should probably address it out loud. With the sounding information that we were looking at on the screen, are the actual soundings, or are they interpreted from the grid? Do the original clean soundings make it to the final product to be used? So talk a little bit about the choices there with running the sounding algorithm and things like that.
Okay, that's an excellent question. Now, in the example that we showed you today, we were doing a sounding selection based off the grid. And so Lee was showing you, maybe if we can go back to it while I'm talking. Lee was showing you the soundings that were displayed from the production database, which are the ones here in black. The grid is the small area, and this could potentially match a chart footprint, for instance, at a particular scale. So this is gridded data. And then we ran the sounding selection off of the gridded data. Now, we were making a presumption, and this is why it's important that we make that distinction, that the BIS is really not a processing software. It's really meant for validated data by the hydrographer. So in this case, the workflow, this data came in as soundings, was modeled in Fledermaus, and added to the BIS as a bag surface. And so, like I said, we're making the presumption that the bag surface is navigable for the mariner, and so we're doing the sounding selection from the gridded surface. Now, if we were to make a sounding, if we were to bring these in as points, then yes, we could also do a sounding selection based on the points themselves. And if we were to do that, we would use Fledermaus algorithms to make sure that they were shoal biased to be used for navigation.
Good answer, Tim. Thanks. All right. Is your labeling for depth standard in ArcGIS or just in this combo BIS? Does that make sense?
Yes. There's two answers for that, I guess. So the question is the labeling engine, or how we label these soundings, is that a standard symbology for ArcGIS, or is that something custom that we've created? So there's two answers to that. We have label expressions, and we also have the symbology that you can apply to a nautical product through the nautical solution that we sell here to make your nautical products. So if I was to make a chart and I have points that are the soundings, I can apply a visual specification which will give symbology to those points accordingly for a chart product. So that is standard functionality within the nautical solution. There's also label expressions. Label expressions are small little scripts that you can apply to a point data set that will give specific symbology. You're looking at a combination of that right now. Just for demo purposes, the red soundings, those are label expressions, and that's why they're not placed correctly. according to the actual sounding location. But we can adjust that. That was just for a quick and dirty symbol. The black soundings that you're seeing, those are actually created through our visual specification tool, and it's been applied to the sounding key feature you see here, or right here.
Right, and so we recognize that nationally or internationally, the sounding placement over the actual depth varies, whether it's in the center of the entire label or whether it's just in the center of the integer. And so that's totally flexible through the Maplex engine, which is standard with ArcGIS.
All right, thanks guys. There's quite a few more questions, but I want to wrap up. So all of you folks who are have sent questions that we didn't answer yet, I promise you that you will get an answer from myself or the Maritime team or both. The one question I will answer, will a recorded copy of this webinar or presentation be available? We always make the recording and presentation available to Fledermaus clients that are under maintenance. Now this one's a little bit special, so I will talk to the Esri team and see what their procedures are for that. So if you are interested, just send me an email. You can reply to that GoToWebinar email address when you get your little thank you for coming thing, and I'll let you know what the story is. But for folks who are clients under maintenance, it will be up on the usual webinar download site probably by tomorrow at the latest. For the rest of you, thanks for all the great questions. We will address them. Thanks for attending, and thank you to Lee and Tim for presenting. Do you guys have any final words before we close down?
No, yeah, thanks for everyone for attending. If you have any questions directly to the Esri side, please feel free to email the bathymetry@esri.com email. If you would like to share, any Acadians out there that would like to share donuts or Timbits, please send us some. Tim and I are jonesing. Thank you.
Thanks again, guys. Thank you all for coming, and hopefully we'll see you on our next webinar. Bye.